Okay, I think we're live now. Just making sure that everything is running on the back end. Welcome everybody to episode 51 of our MakerBot Chats. My name is Felipe. As always, it's a pleasure to have you guys join us this morning. And yeah, today it's going to be a fun, well, it's always a fun one for me, I guess. But pretty interesting one. We are going to talk about layer lines and part orientation. I got my macro lens. I'll be showing you guys some detailed shots about these parts. I have quite a few of them for you guys to see. From a bicycle pedal to a pseudo scale model of the James Webb Telescope array. This has way more hexagons on it, but yeah. Half of a gripper, so we'll be talking about the strength that implies or that comes with the different part orientation, and also this very peculiar metal print of a helical drive gear. The point today is to discuss a little bit of what happens as you move things around in MakerBot Print before you slice them. In 3D printing, as you guys might know, you are trying to describe an object based on multiple layers, right? So essentially you're creating sort of a cake of an object. You're taking one particular part, in this case a pedal, slicing it, like literally cutting it into many different slices from the bottom up to describe that shape. And then each of those slices will be printed one at a time, right? It's what we call layers, right? Each of these layers will be printed out by the machine one at a time. Now, there are implications of that slicing process, and all printers use some type of slicing process. That's usually what's referred to as layer resolution. That means that you can change the amount of layers that will describe that object. By having more layers, technically you are adding resolution to that object, right? So if you imagine this object being sliced up into 1,000 layers versus 2,000 or 5,000, you can increase the number of layers and thus the resolution of the object. Now there's a limit to how thin a slice can be. Usually you'll hear manufacturers talk about somewhere between 100 microns and 200 microns, kind of like the standards. There are a few slicers out there that will allow you to slice for 50 microns or less. That's, in my opinion, really hard to achieve with any type of hardware, right? 50 microns or less, we're talking about like steps of, less than the width of a human hair. And the control that you need to do that doesn't really come with any one of the standard stepper motors. So the stepper motor is actually the part that the printer will use to change the step on the printer, the layer lines. And to be honest, many printers share a very similar hardware element on that stepper motor. So anybody who's promising more than 100 microns or less, I guess, than 100 microns layer resolution, I would be aware of that, because unless you're using a laser printer, in which case it can be a little bit more manageable, it's really tricky. And not only that, it'll add a lot of time to your print. So bottom line is, usually you'll see somewhere between 100 to 200 microns for the layer height. And then depending on how you orient your part, you'll also be controlling and changing how those layers stack up, right? You can imagine how this object, and I'll be jumping into cloud print in a second, right? But this particular pedal, you could print it, flat on its side, or I guess on its face, or completely vertical like so. So if you imagine, if my hand was the build plate, I could print it like so, perpendicular to the build plate, or flat against the build plate. Now, each of those orientations will have implications on the number of layers that you can achieve this. You can imagine if you're looking from the top view, so this should be able to give you a better sense of how those layers stack up. I'll change and add the macro lens here real quick so that I can bring in this part a little bit closer, right? But you can see how this particular part, the layer lines are actually oriented. If I bring my finger in, here we go, this way, right? You can start to see the layer lines as I'm using my macro lens stacking up from the bottom here all the way to the top. Now, I could have printed this part, instead of being up against the build plate like so, I could have printed it flat against the build plate like that. Now, the implications of doing that actually could benefit in some cases both the quality and the performance of the part. In this particular case, printing the pedal with the layer lines aligned parallel to the force the force that's being applied. So if you can imagine, let me remove the lens real quick. If you can imagine me stomping my feet against this pedal, right? The force that I'm applying is coming directly in line with the layer lines. That means that it's actually more prone to be delaminated when the force is applied. So all in all, what I'm saying is probably for this particular use case, a flat alignment would be better, just because then the layers are stacking up against each other, meaning when the force is applied, right? So if you imagine like the layers being sandwiched like so against the perpendicular force, then as I'm applying the force is not actually, it's not compressing on, actually it's compressing those layers as opposed to shearing those layers as would happen here, right? Because the layers are now aligned with the force that's being applied. If I'm applying the force this way, I'm actually following the same path as the layers would be. That means that I could be having a less robust and less, more prone to the lamination part. That's just a natural part of the process of 3D printing. Any printer will have, for any printing process, you will have to have these type of considerations in mind. Why? Because all printers, no matter which system you're using, whether it's FDM, laser, powder, all of them will be starting off from that very first element consideration, which is layers. You're splitting an object into layers, and those layers in turn create micro steps within that part that can affect both the performance and the look and feel of the part. So in this particular case, I printed the pedal this way with the layers oriented perpendicular to the build plate like so, because I wanted to have as much detail as I could here as I build up the object, right? Shallower objects, and I'm going to take this part, well actually let's take this metal part instead as an example. Shallower objects where you have the layers aligned almost flat up against the build plate like so, we'll have a harder time, and I'm going to use again my macro lens here, a harder time in describing fairly organic shapes. So if I bring this part really close to the camera here, let's see, just trying to get the camera to focus on my part. Is it focusing? Right. So you can see how the layers, there's not, since this part is fairly shallow, there's not, no matter what I do with this orientation, there's not a lot of room for me to actually stack up those layers in. If I bring in, here the tweezers should work. If I want to have something fairly sharp to be able to show this to you guys. You can see how here, actually let's do it on this side because this is the side that you will have a better view of, right? If you see like the layer lines here, there's probably, we could count them on. There's no more than, I would say, 20 or 30 layers describing this element. And you can actually count them here because of the fact that this angle is very shallow, right? It's almost flat. It's not completely flat, so if I look at it sideways, it does have a gradient. Like, you can see like this conical element coming from the base and flaring up to the top. But the shallow my geometry becomes, the less layers that I'll have in order to describe that geometry, right? You can see that happening both in the teeth here, the teeth of my part over here. You can count the layers, and if I rotate it well enough, you can also see the layers coming into focus right here inside of the part, right? So you can start to count those layers out and probably see that there's about, say, 30 layers of resolution there. As I said before, this number of layers is actually defined by the layer thickness, and there's a limit to how many layers you can have depending on how shallow your part is, right? If I wanted to have a better description, like a much smoother transition on those layers, I would have probably had to print this part instead of flat against the build plate like so, perpendicular against the build plate, so that I have many more layers describing that object in my printer. Now, the compromise with that is that I would be having then an uneven distribution of the layers, I would say. Like, you can imagine how by splitting this object this way instead of flat against its back, the layers will have then, I would assume, this is without a particular testing in mind, but I will have will be more likely to shear amongst themselves depending on the way that I apply the force here, right? So it all changes depending on the part that you're trying to print. And with that, let's jump real quick into Cloud Print so that you can see, and going back to the pedal example over here, how those implications will affect not only the way that your part looks, but also the time that it takes for you to print a part. Right now, I have this particular pedal, so it's the same, here we go. It's this same pedal imported into Cloud Print, right? And what I'm doing is I'm just slicing it as it was printed, with supports in this case. So you can see how the part itself, it's thoroughly covered in supports. There's a lot of supports. I can actually hide them a little bit so that you can see how the part will look like at the end. I'm slicing it for my method X with ABS and rapid rinse. But since the part is oriented, parallel like that against the build plate, I will need a lot of support that will help me bridge over this opening over here in the pedal, right? So that's why there's so much support being created. Now, two things will happen with this particular orientation. I may have, let's remove the support again, but I may have a much cleaner view or a much cleaner part with a nicer sort of surface finish here, especially in order to describe those little dimples that will act as a means to attach my foot to the pedal. However, the layers, as I said before, are now oriented parallel to the way that the force that will be applied to the pedal will be. So that probably is not the best possible option or alternative for part strength. It might be better for to describe this threaded element, because sometimes the actual surface finish is not only related to the look of the part, but also to the smoothness of some of the more technical components, specifically like in the case of threads, or if you think about threads or teeth in a gear, we're not longer talking only about surface finish for the sake of appearance or for appearance sake, but also surface finish for performance sake. I really want, for example, these threads to be super clean, so that when I come in and thread, or actually put my pedal cover against that thread, it's going to slide in smoothly. But again, as I said before, downside, I'll need a lot of support. I'm also probably risking delamination as I apply force to that part. Now, this particular orientation takes, here you can see, takes me about 20 hours, well 18 hours to print. Now let's write that down real quick. So 18 hours on this orientation. And let's jump out of the preview, rearrange my parts. So if I'm actually, by the way, I'm using our Cloud Print software. If you haven't, you should definitely give it a try. I can just select one of the faces. In this case, I want this particular face to be my bottom face against the build plate. Hit done. Really great piece of software. It's completely free to use, and you don't have to have a printer to test it out. So if you go to cloudprint.makerbot.com, you can test it out right now. But in any case, I've moved my part so that it's flat against the build plate. It does have this offset, based on the dimples that are describing the part. So it will still be a little bit further up and will require a fair amount of supports in that area. But let's see what happens when I hit print preview. I didn't change any settings on the material side or on the density, the infill, anything other than the standard default ABS and rapid rinse combination for slicing. So I'll give it a second to slice, and then I'll also encourage you guys to send out any questions that you have. We are, Alejandra is as always in the back end collecting those so that we can answer them as we go. I'll let that slice for a little bit, and I'll come back to some of the other examples that I have here, right? Because as I was saying, like, it's not only the part orientation and the layer lines will not only affect the way that the part looks, but also the way that the part performs. Let's look into real quick that thread element that I was describing before. So if I bring in, and this is actually printed in nylon carbon fiber for those of you guys wondering. Let's try to get this part to focus for me. Come on, you can do it. Will it do it? I don't think it wants to, right? Almost, there we go. Right, you can see like the thread in there. Here we go, how clean it is, right? That's a very fine element inside of my part. And you can see like the shiny, you know, like last edge of the thread and how clean it's actually coming out of the machine. So definitely in part due to the orientation of the part, right? So I have a lot of layers describing that particular thread. In this one, it's close to 1 centimeter section, so about a little bit less than ½ an inch. I probably have a good 150 layers to describe that. Especially, you know, you can do the math. I was using 200 microns for steps. So if I have 100 millimeters, so that's 1,000. Does that make sense? No, 500. 500 layers to describe that. Now, oh, by the way, this is now sliced. So again, looking at my part sliced, the same pedal, it's saving a lot of time, right? So the previous slice would take 18 hours. This one takes 8 hours and 48 minutes. That's, you know, 9 hours. That's almost half the time saved. That's a lot. And not only that, but now I can zoom in here and see that actually my layers, I mean, this is of course expected, but it's just so that we can double down on this idea, right? My layers are now properly aligned, perpendicular to the force that's being applied, right? So you can imagine how me stomping on the pedal, I'll be pushing in from the top down, and the layers are stacked up flat up against that, you know, perpendicular against that force. I will be getting a lot of support now generated here. In the previous orientation, I didn't have any supports on the inside of the part, so that support might be tricky to remove if I'm not using soluble supports. That's an important thing to keep in mind, especially for something as sensitive like threads. So here are my threads, right? They look fairly clean, but when I add the supports in there, it might be an issue to remove depending on the type of supports that you're using. In this case, I'm of course using Rapid Rinse, which is our super fast dissolving supports. That's going to help me a lot in the removal process, but again, it's always kind of like a balance of different situations and different considerations. In this case, do I want a part that will be sturdier, or do I want a part that will look and have a finer finish, surface finish to it, right? So again, it all changes. I'll be jumping into some of the questions that are coming in right now. So is there a thought process for how to orient a part for printing? Yes, that's kind of what I'm describing right now, right? You'll have to consider, I would say, maybe three main things overall. First of all, how are you, and let me just switch back to my parts view over here, I'm moving my lens. But first of all, first consideration, how is the part going to be withstanding a load, right? Does it require to withstand some sort of force being applied to it? That probably will tell you a lot of information on how to orient your part. For example, what happens here in this gripper, this is actually a gripper, it goes that way. I don't have the other half of it, but it's essentially 1/2 of a gripper element, right? And this part, you can already see it by the raft itself, was printed flat on its side. This means that all of these layers are now, you know, will have a greater resistance to force being applied from the top than from the sides. Although this, we have to say, it's a very shallow part, so there's not a lot of area to apply a force laterally here that can shear my part. But in any case, first consideration when printing a part and orienting it is it going to withstand a considerable amount of force? And if so, where is that force coming from? In the pedal, I think, in the pedal example, it's a clean way to look at it. My force is most of the time, 90% of it will be coming from the top down. Therefore, I should probably consider having my layers flat against the build plate, which would make them perpendicular against the force that's being applied. Now, second consideration, how does this affect my material usage? Meaning, how much support material will I require by printing this particular part this way versus this way, right? If I print it, if this is my build plate and I print it as I was showing you guys before on Cloud Print, you know, oriented like so against the build plate, then all of these insides will be probably covered up in supports because, you know, this bridge at the top is something that is unsupported at the moment. However, if I was to print it flat on its side, I will be using way less support material, way less material overall. Well, the model material will be the same amount, but in doing that, in reducing the amount of support material, I'm not only saving material, but also saving time, and a considerable amount of that, right? Because as we saw here, it goes from 18 hours to about 9 hours here. So almost half the time saved just by changing the part orientation. Again, to recap, consideration one, is this part going to withstand a force applied to it, and how is that force being applied? Consideration number two, how will this affect my material choices? How much difference does it make when I'm talking about the supports that I'll be using and the amount of support material, because it affects the time. And the final consideration, but I think it's also super important, is going to be how will my part orientation affect the actual appearance of my part, right? Do I need some, is that a consideration? Is the final part super shallow and has a lot of detail, therefore I would rather have, you know, something, I would rather orient those layers against that detail so that it's actually allowing me to describe it in many more layers as opposed to just a few. So that's kind of the final consideration. Not all of the parts will have all of the considerations, right? In this case, this is just a demo part. It's just a model, so I don't really care about loads being applied, but I would probably care about the look of the part, right? So as you can see, like if I bring this one was, instead of a method, it was printed on a sketch, but same idea, right? The point stands where you still have to think about all of those layer lines. So you can see with this, you know, as I move the part and as I shine light into the layers, there's a lot, the layers are really clearly visible here, right? So maybe the part is not going to be withstanding force, or there's no force being applied to this particular part. It's just a model, it's just a scaled model. But I still have the other two considerations, which are how will changing the orientation of my part affect the supports that I'm using, right? If I'm printing it flat like so, didn't require any supports. If I was to print it sideways, you know, this is my build plate, and if I print it sideways against the build plate, or actually standing up on the build plate, I would probably need supports just to make sure that it's not wobbling around, and especially like on these outer edges of the circle to make sure that I have something to print on. That in turn will add a considerable amount of time, but will probably give me a cleaner outlook here, or a cleaner result layer-wise and surface-wise. Let's go back to some of the questions that you guys have over here. Okay, can I get rid of layer lines? There's people who have actually, you know, suggest using some weird combinations of acetone and microwaving. I don't really recommend those. I think it's, first of all, it's a very toxic combination. It's, I wouldn't say it's safe. I've tried it before. With certain polymers, specifically with ABS, it can help a little bit with how smooth a part looks like. I'll bring another example here to the camera, right? This particular sphere. So anything with curved surfaces will have a noticeable effect on as the layer lines appear, right? If you want to get rid of the layer lines, I would strongly suggest either painting the part, post-processing the part, as opposed to trying something chemical. You know, the parts are a byproduct of the 3D printing process. Personally, I like them more often than not. They tend to look really interesting to me in describing that shape. But yeah, so short answer, yes, you can get rid of many of them by changing the orientation of the part. But not all of them. So it's something that you just have to consider as part of the process when printing something. What causes over extrusion? Overextrusion is caused by the extruder actually pushing more material than the build plate or the part is actually able to retain, right? Which means I'm moving the extruder at a slower rate than that which I'm moving the extruder at a slower speed than the speed that the material is flowing in, right? So essentially sort of like saturating the material out and causing it to spill over. I don't have a good part to show that. Well, maybe on the base of this. So you can see actually in the raft element here, the very base of it, there's a little bit of what people call sometimes an elephant foot. That happens because on the first couple of layers, we're actually actively pushing the extruder into the build plate just to make sure that the part is adhered correctly. So yeah, overextrusion is essentially similar to the elephant's foot sometimes, but it means that there's a little bit more material coming out from the or being pushed out of the extruder than what can be actually deposited as the extruder moves around. What happens when the same object is printed with different orientations? Well, as I said before, you can have many things happen. You can have changes in the look and feel of the object, so the appearance of the object. You can have changes in the performance of the object because of the fact that the layers will affect the way that an object is able to resist forces being applied to it. And you can have changes in the amount of material and time that it takes to print a particular object, right? An orientation can dramatically affect, as we saw with this particular example, can dramatically affect the print times for a particular object. Is build direction the same as part orientation? Yeah, I would say so. It's, depending on how you orient your part, the print in turn will be building that part out of the slices that are generated by our software. What should I consider for optimal results? TLDR, really quick, just like the overarching takeaway here is going to be three things. Sorry, and bad hand. So three things. First of all, is your part withstanding a force or not? Try to make your layers perpendicular to the force being applied. Second consideration, materials and time. Will changing my part orientation affect the amount of supports that are required for this part? And third consideration, appearance. Will changing my part around change the way that I'm able to describe a particular shape and the finish of my part? So strength, material, and aesthetics. Those would be kind of like the quick TLDR of today's conversation. So again, as always, thank you guys so much for joining today. It's always a pleasure to have you guys here. You can reach us out at hello@MakerBot, Felipe@MakerBot, and @MakerBot in both Instagram and Twitter. And for now, that's it. Let us know if you have any more questions, if you have any more ideas on topics that you want us to touch on and cover. But for now, thank you guys so much for joining. I'll see you guys next time. Bye.